So let's talk about section 6.4, which is finding values of normally distributed random variables. Understand that we've already looked at random variables in a normally distributed case. And what we're going to do is we're going to identify the z-values for those given areas under the standard curve. So basically in this section, we will work problems from the previous section in a reverse setting. So we're still working with those same four types of problems, which is the area to the left, area to the right, area in between, and the area of the tails. Okay? However, this time though, in particular amount of area is what you're going to be given, and you're asked to identify the z-score that marks that cutoff point for the area under the normal curve. So our questions may be as simple as, what is the z-value that has the area of 0.7357? Now remember, that area under the curve is the same thing as the probability. And what I want to pay attention to here is it's asking me for what is the z-value for the area of this number and to its left. So in order to sketch the graph of what area we're going to need, I really do find it very helpful that if you will actually draw a picture for each single time here. And we are looking at the area to the left. So we do know that once we draw it, we know that we're going to end up with a positive z-score because 0.7357 is bigger than a half, so it's got to be bigger than 0 there. Okay, and this is what our graph is going to look like if we were to draw it. And again, I am searching for this area right here. This is what I want to know. This is the probability or the area that I'm looking for, and this is the answer I want to get. So on our way that we're going to look at this is, one of our ways is we can scan through the interior part of the table B. Now I say table B from appendix A because we're looking for an area that is got a positive z-value because it's greater than 0.5. So we're looking for 0.7357, and you're going to have to, once you find it, look up and to the left to find the corresponding z-value, which is going to give us a 0.63. So this is what our table looks like, and again, I'm going to have to kind of scan through until I see 0.7357. Here I see it. So again, left gives me 0.6, and then up is going to give me that second decimal place, which is the 3. Okay, and so that's where I get my z-value there, is that z equals 0.63. Okay. Now, again, this is one way to do it. And again, this answer that what we're looking at here, our answer is actually coming from this and this combined put together. Okay. But don't think that this is the only way. So remember that you have these calculators. We can also use our calculator as well. So let's also demonstrate how to find it using the calculator. First, you're going to start by pressing second vars, and then you're going to actually look at option 3. Option 3 says INV norm, which basically is the inverse of a normal. Okay. This option requires you to enter the area to the left of a z-value, and you're going to find basically your p-value in there. Now let's take a peek at this so you guys can see exactly what it looks like. So on my screen you should see the calculator here, and again, second vars and number 3 for inverse norm. Now for those of y'all that have a TI-84, you're going to see this pop-up screen here. Okay, and you're literally just going to type in that area, and because we're dealing with z, we're going to use our mean of 0, our standard deviation of 1, and again, those that have a TI-84 that has been upgraded, you're going to see the option for left, center, right. So you actually have a little bit more than most other people. Those that have a TI-83 will not see this left, center, right option, and you will not be able to enter in left, center, right option. So what you'll end up doing is, guys, I'm just going to kind of do these pretty much from the left every single time for the rest of the thing. But for those of y'all that have a TI-83, you're literally going to see inverse norm. You're going to type in the probability that you have here, or the area under the curve, your mean, and then your standard deviation, and then close the parentheses. Your calculator is automatically set. If it doesn't give you that left, center, right option, we'll always find the left, okay? And when you do that, and as you enter it in there, okay, here you can see it for the two different ways. So this again is going to be my TI-83s, and then my TI-84s that have the nicer upgraded. So here's my TI-83. This is going to be for my TI-84s pluses with the upgraded left, center, right. You actually have to make that choice left, center, right. Okay, let's try this again. So we're going to find the value of z such that the area to the left of the z is 0.2000. Okay, now the first thing I want to do is I want to kind of sketch my graph. That's the first thing I want to do. Okay, and as I'm sketching my graph, notice this is my area here, and I kind of want to make note that this area is less than 0.5, which tells me that my z value is going to be negative. Okay, so since I know that my z value is going to be negative, I'm just going to kind of pick some place to the left of 0 and say z equals, and that's what I'm looking for, and then shade in this area, and that's that 0.2000. Okay. Now again, we can take a look at our nice lovely table here. Because I know that this area is 0.200 and we're looking at kind of to the left of 0, this is going to be a negative z value, which means I will need to take a peek at the appendix that has all the negative z's on it. Okay. Now you'll notice that this one here, you're not actually going to find the exact z value. Okay, so you'll get close, but you're not going to find the exact one. So really what you want to kind of do is you're going to basically be approximating. And so as I can take a peek at our nice lovely table here, and let's take a peek at this table, okay? This is the closest I can get to it here. So I'm going to have to say it's approximately a negative 0.84. Okay, now this again is kind of approximate. The table's only as good as for all the probabilities that you have with you. Okay, your calculator is going to be a little bit better. Okay, so with our calculator, you'll actually notice that you get a more accurate area. So again, second vars, number 3, and then we're going to type in our area under the curve, comma, our mean, comma, our standard deviation. And again, for those of y'all that have the option for the left, center, right, go ahead and just put that left in there. And you'll notice that you get the same thing as we did with the calculator, but notice it's actually a negative 0.8416, so like it's a little bit more accurate at going this route, but we do still round it 2 decimal places. So let's change the question up a little bit. What if I ask you what z value represents the 90th percentile? Okay, so we've talked about percentiles in previous chapters. So the 90th percentile is basically the z value for which 90% of the area under the standard normal curve is to the left of it. So basically, when we look at that, that basically means the area under the curve is 0.9000. Okay, and it's everything to the left, so our graph would look something like this. Okay. Again, if you are looking for this using the tables, it's going to be an approximation. You're not going to find an exact. Okay. So looking at the table, you get really, really close to it. We don't get there, but we get really close, so it kind of rounds to it. So basically for this one here, I'd have to say 1.28. And again, this is kind of, again, approximation. Using your calculator as an option, you again are going to plug in second vars, and then number 3 for inverse norm, enter in your area under the curve, which is also known as a percentile now, comma 0, comma 1, and you'll notice that as we look at that, it is a little bit bigger. Okay, but it doesn't matter whether I have that left option in there or not. We're going to always assume that it's to the left unless stated otherwise. And it ends up being that 1.28, which is pretty much what we got from the table. Okay, so let's go a little bit different. Now let's consider the problem which gives the area that lies to the right. Now, the method for finding z-scores using the cumulative normal distribution tables for finding area is only for those tables are area for the left. Since the area is not really given, what we have to do is we have to find the corresponding area that's actually on the left of the curve, which is where these drawings are really helpful. So if I ask you for what is the z-value for the area of 0.0096 to its right, the first thing we want to do is we want to sketch the graph of the curve. Now again, I said the area to the right. That's really important to kind of notice like where it's saying. Is it left, right? Okay. So we do know that because it's the area to the right that we are going to have a positive z-score. And we have to remember that basically all the area under the curve has to add up to be 1. So 1 minus this 0.0096, which is going to give me 0.9904, will be all the area to the left. Okay? So here's my drawing, and again, this is what I'm looking for, is I'm looking for the z-value that has this area here. But because when I'm looking at the tables, I will need to use this option here. Okay? So on the table, I'll be looking for 0.9904. Okay, so as I look at the table there's my 0.9904. Again, so that's going to be a 2.3 and then 4. Okay, and that's going to be the z-value. Now, if you are looking at a calculator, again, we can still use the calculator. Now, please be aware that I'm only going to use the calculation to the left here. And the reason being is those that have a TI-83 do not have that left, center, right option. Those of y'all that have a TI-84 do have a little bit of an advantage on this one. So I will still need to do that whole 1 minus 0.0096, still putting in my 0 and 1, and you'll get that approximate 2.34, and so you'll get that option. Again, this is with it always being a left option. Now, this is the one time I'm going to do this. So the alternative method for the TI-84 Plus is the ones that have the option for the left, center, right. You can actually enter in the area, that 0.009601, and then choose right, and it will also give you the same answer. Okay, but please understand for the rest of this video, I am only going to use the left method, and you will need to make that adjustment as you see for your problems. But again, I'm doing this because not every calculator has that left, center, right option, so I'm always going to assume everybody's going to be on the left. Okay, our third type of problem is in which the area lies between two z-values. And these ones actually require a bit more work. So the first thing we'll have to do is we'll have to find the remaining area in the two tails by subtracting the given area from the total area of 1. Okay. Next, we'll have to divide the difference by 2. So again, this will tell me the area of each of the individual tails. And then we can use the technology or the table to find that negative z value using the table or the technology. Okay. Because the question asks for a positive value of the z, you just have to switch the signs, and therefore you have now obtained the correct answer. Okay, so ignore my little thing right here real quick. Finding the value of z such that the area is between negative z and z is 0.9. So the first thing I want to do is, because it's 0.9 here, I'm going to say 1 minus 0.9, which is going to give me 0.10. So in our sketch, our shaded area is going to be the 0.9, which is going to be in the middle. And again, the curve is symmetric, so the area to the left and the right is going to be subtracted from 1. It has to be divided equally. So I'm going to take that 0.10 and divide by 2, which is going to give me 0.5. Okay, and that's going to be the left tail and the right tail. So the left tail is 0.05, and the right tail is 0.05. And then in the middle here is 0.9. And again, if you add all this up, it should equal 1. Okay, now again, realistically, remember that if you are looking at the tables only give the area to the left, which is why, since the table is only given the area to the left, we're going to use this probability as what we're looking for. Okay, and again, this is the reason why I take a picture of this, that we've done the drawing. this is the only thing that will show up in the table, because remember that this is all the area to the left of this negative z value, okay? So that's the only one that we can find in the table easily enough without doing a lot more extra work, okay? So in the table here, we're going to notice that we kind of find what we're looking for. And as we take a peek here, I kind of get 0.0495 and 0.0505. Now, as I'm looking at this, these are both kind of equally close to 0.05. So that does mean that pretty much it should be halfway in between these two z values. So I have a negative 1.6, and then I have a negative 1.65, and a negative 1.64. Okay, so since it's exactly halfway between those, we can just basically add those together and divide by 2, or just basically just add a 5 to the very last one there, and that will tell you what that value is in the negative form. So it's going to be a negative 1.645, and to get the positive version of it, we just drop the negative sign. Okay. For those of y'all that have the TI-83 calculator or the 8084, we're going to use that finding the area to the left to get that negative z value. So again, that negative z value was at 0.05. So again, this is kind of what we're doing here. And again, you can see here that's where we get that same answer of 1.645. Be sure that you are taking a peek at these ones here to be able to see like what you're going to be rounding to. Take a peek at each individual problem. Okay, this is the only part where I would say that those that have a TI-84 do have that advantage to be able to use that 0.9 in the center area. Okay, now our final problem type is the area which is contained in a standard normal curve. Again, this is if it's just in those tail areas. So since again the curve is symmetric, we're going to divide the area in half and only look at the left tail, and then we're going to find the z value that corresponds with that area alone. Okay, and again, all we have to do is once we find that, just basically pull the negative off and switch it to the positive to get the other z that we need. So find the z value that the area to the left of negative z plus the area to the right of z is 0.1616. Okay, so this is basically telling me that the total area in both of the tails is 0.1616. So the area in one of the tails will be half that, or basically 0.1616 divided by 2, which is 0.0808. So my picture should look something like this. So I'm going to take a peek at this one over here. So this is the one I'm going to find first, because again, if I get this, this is going to be exactly the same thing, but with dropping the sign. Okay, so I'm going to look for a 0.0808 in my table. And again, as I'm looking at the table, you're looking at the interior when you're given an area. Okay, and that's going to be what I'm looking for here, 0.0808. And again, my answer is going to be that negative 1.40. Okay. And then I just drop the negative sign and make it positive, and then I've got the other version of it, which is the other side. Okay. Now, again, for those of y'all that are using the calculator instead of the tables, you're still going to have that same method. You're still going to want to find that negative z1 first. So we're going to go enter inverse norm, and then we're going to put that area and divide by 2 so we only get part of the tail. And then 0 and 1, and again, as shown below, you're going to see that this is going to give you that rounded area of 1.4, and you're going to have a negative 1.4 and a positive 1.4. Okay? Again, I'm only looking at the left here. Now, all the previous examples have asked for values of z, but understand that these questions could actually ask for a normally distributed random variable, which would be those x variables. So recall the steps for finding the area for a normal curve when given an x value, okay? So using the values of the mean and standard deviation to convert from an x into a z value, and we can use the z value to find the area under the standard normal curve. Okay, this is what we were doing in previous problems. So when we want to basically find a normally distributed random x value given an area under the curve, the first thing we'll have to do is we'll have to take that z-score formula and use a little bit of algebra and solve it for x. So again, if I'm dividing by something, I'm going to multiply it across, and then I'm just going to add the mean over because it was subtraction over here, so it adds over here, and that's going to now be solved for x. Now again, you don't have to memorize this new formula because it's literally this formula here just solved for x, which is kind of cool. Okay? So now that we've got that, okay, you can use this x equals z times our standard deviation plus the mean, which is the altered formula. And so now if you're given the area under the standard normal curve to find that corresponding z value, get the z value, plug it into this formula, and then you'll have your x. Okay? Now, let's give this a shot. So if a normal distribution has a mean of 28 and a standard deviation of 2.5, and the value for the random variable, that area to the right, is equal to 0.67, okay, let's start off by reminding ourselves that we're going to have to do these in reverse, okay? Again, taking a peek here, what do they give me? They gave me the area to the right is equal to this. We're wanting to know what the random variable x is. They gave me a mean and they gave me a standard deviation, and they told me that it was a normal distribution. Okay? So with all of that right there, I already know that I'm looking at some type of normal curve. Okay? Now this is 0.67. So here's 0, and I know from like here to here is 50%. And I know from here to here is 50%. But again, remember I said all the area to the right, so all of this is going to be a little bit bigger than 50%, which is actually going to be our 0.6700. This is the area I'm looking for. Okay? And I also know that basically this is that x value that I want to know. But I'm going to start by finding the z first and then use that to translate to find what my x is. Okay, so remember what the steps are in reverse. So we're going to use find the value for the z. We will use the TI-84 calculator plus to find the solution to this question. So this will kind of help you guys out a little bit. For those of y'all that are using the tables, it does take a little bit more work, okay? So the first thing, if you're doing the tables, then you're going to have to use the formula part. So if you're using the calculator, it ends up being a little bit nicer. Okay, so let's take a peek at the calculator. Okay, so I've got my calculator up on screen. So second vars and number 3 for inverse norm. Now remember when we were doing these earlier, notice that my mean and my standard deviation are 1. I kept my mean of 0 and my standard deviation of 1 because we were looking for z values. But now this time I'm looking for x values instead. So as I enter these in, I am going to put in my lovely area under the curve. And again, I'm going to go, my 0 is going to switch to what my mean is. And I'm going to change this to whatever my standard deviation is. Okay? Now, do be aware that, again, take a peek at this. This is all the area to the right. So if you have this option, you can click right here. But most of us don't have the left, center, right option. So I have to basically say that this is 1 minus 0.6700. Okay? Now, if you were looking at the table, this is what you'll end up finding as your z value, okay, which is basically a negative 0.44, okay, and then you'll have to do your conversions, okay. So with the conversion, that's where you actually use that formula, which is your z times your standard deviation plus your mean. When you do this, I do recommend taking about, as if you're using the calculator, all the decimal places that you can get before you do any rounding, okay? And you're going to get that x value to be approximately 26.9, okay? But notice again, for those of y'all that had the calculator, we can actually kind of skip that second step if you have a TI-83 or 84 calculator. Okay, this does not work for those of y'all trying to get out of this course with only using like a TI-30. You will have to use those tables, and again, those tables do have a bit of an extra lot of a lot of extra steps, sorry. Okay, so if you are going to be doing these here, again, you're still going to actually put in the x values mean and the x value standard deviation, but you still want to make sure that you get that 1 minus 0.6700 in there. Okay, and you'll also get that it's approximately 26.9. Again, I'm doing this because, again, pretty much everybody that has a TI-83, this is what your screen looks like for a TI-83. It's an automatic left option. For those that have a TI-84, you do have an option for the right, but again, I'm teaching it all left because not everybody has the left, center, right options. So let's give this a shot. So the body temperature of adults are normally distributed with a mean of 98.6 and a standard deviation of 0.73 degrees Fahrenheit. What temperature represents the 90th percentile? Okay, so the first thing I'm going to do is I want to draw my picture, and this is what's going to help me out tremendously. And for you guys that are especially my visual learners, it's really going to help if you can get your picture drawn. And you want to actually draw a picture each single time. I cannot stress it enough that the picture really does end up helping. Okay, doesn't have to be perfect, just kind of get the basic idea in there. Okay, and here's where my mean is. And because it says 90th percentile, I'm going to be like, psh, okay, so this is 0.9000. So all of this is being shaded. Okay, and this is what I'm looking for here. They gave me a mean of 98.6. They gave me a standard deviation of 0.73. Okay, and again, this area that I'm looking for. And again, this is, as you guys see, when you use the word percentile, it's an automatic left. Okay, so pulling up my calculator here, I'm going to clear out what I have so I can start fresh. So second vars number 3, I'm going to put in that 0.9000. You don't actually have to put all the extra zeros there, but I like to put them there just in case. I'm going to type in what my mean is. I'm going to type in what my standard deviation is. Okay, and again, I am going to click paste, have to put it in there one more time and hit enter. Again, those of y'all that have the TI-83s, remember that yours is just going to put that inverse norm, and you're going to have to type in 0.9000, comma, 98.6, comma, 0.73, and then you won't actually have to worry about the left, center, right. It's just always an automatic left for TI-83s. And then there you go. There's your answer. Okay, let's try another one. Let's assume that the length of a newborn full-term babies in the U.S. are normally distributed with a mean of 20 inches and a standard deviation of 1.2 inches. What is the minimum what is the minimum length that a baby could be and still have the length that is amongst the top 25% of the baby lengths? Okay, so talked about normally distributed, right? So let's go ahead and just get our normal curve up there. Okay, and I'm just going to put my mean here, just in the middle somewhere. Now it says top 25%, so basically here, this here is going to be 0.25, right? That means everything over here is 0.75. Now how did I get 0.75? Well, they should add to be 1, so this is where I'm getting that number from. Okay, and again, I'm just going to write my other main stuff down. We know that my x is normally distributed with a mean of 20 and a standard deviation of 1.2. And again, I'm looking for this x value. What is the minimum length, meaning what is this value here? Again, my calculator will only give me this area here. So even though I'm looking for the minimum, this x value that gives the minimum for that 25%, it's actually going to be the maximum of the high 75%. Okay, so again, let's take that calculator and see what we can get. Okay, so again, I'm just going to clear my calculator so I have it fresh. Second vars number 3, and again, I'm going to put the area 0.75. Okay, now you guys can actually put in 1.0.25 or you can put in the 0.75. It's actually going to work both ways there, which is really nice and cool. Okay, and I'll show you how it works both ways. So second vars number 3, and instead of that I'm just going to put the 0.75. So whether you do the 1 minus 0.25 or the 0.75, you're going to get the answer there. And that kind of tells me what my answer is going to be. Okay, so the length that represents the 75th percentile or also the top 25th percent is going to be that 20.8093877. Do be aware that when you guys are working these out, uh, as you can see with the calculator, you get this really cool, just really nice answer here. And they end up being the exact same. Disregard, I had a typo on the second thing there. But they end up being the exact same answer whichever way you go, whether you do the 0.75 or the 1 minus 0.25. Okay. And just kind of take, as you're working your way through these problems, be sure to draw a picture. I find drawing a picture is really helpful because it tells you kind of what you do know. And you'll notice as I drew my pictures, I wasn't being 100% accurate, like exactly where it would be on the curve. I just want to get the base idea down. I'm not labeling where every standard deviation is falling. I just need to know where the mean is and where the basic x value is. But I do make note of my mean and my standard deviation somewhere else, just not on my normal curve itself. Because realistically, that's not going to have any effect on what the x is going to be. And I don't want to put too much information into my drawing. I just want to get the base ideas down, which is basically where's the area I'm looking for. Would it be a positive? Would it be to the left or the right of the mean, basically? Is it a positive or a negative z value, or is it to the above or below the mean basing for my x values there? Okay, and guys, that is everything you need to know for this section.